after
sorry for the wait, guys.
Yeah, sorry for the wait, guys. We didn't know that apparently you have to pay for the projector in here, so we had to very quickly get our own. But nonetheless, we're here, and we're going to hear and talk to you about Micromouse. So if you want to go ahead.
Wait, am I the one that can switch the slide, or is that you? Okay. Well, anyway, welcome to Micromouse. Congratulations on being accepted. You guys, it was great reading through all your applications. It's going to be a great year.
Yeah, this year was actually the first time that we've actually had to fill up the entirety of Micromouse, so congrats to you guys for coming out here and making it. Yeah, so now let's get started. We're going to talk to you today probably for about 20 minutes about, just the overview, some logistics, and our first lecture, a little bit about power management on our RAT. So now let's talk a little bit about you guys, actually. Oh wait, no, we're doing details. But anyways.
All right. Anyway, deposits. That's an important thing. It's $40. Pay on Venmo if you can. If you want to pay in cash, that's also fine. Just you can come up to us at the end of the lecture or some other time during lab hours or yeah. Anyway, the deadline for the deposit I think is this Friday.
It's on the syllabus.
Yeah.
And yeah. So anyways, there's our syllabus. I'm sure you guys hopefully have seen it and read it over it like 3 times by now. But you'll find all of the information like rehashed again there, as well as.
Yeah, join the Discord. There's also the Micromouse role on the Discord. If you go to the Add Roles channel, make sure you're in there. We'll send some announcements out there as well. Or you can also use that to ask for help, in addition to Piazza, which you guys should also join. We sent out that link. I think we have 39 people in it so far, so about half of you guys, maybe more of you guys have done it in the last few hours since I haven't checked.
But yeah, we'll be putting all of our main class resources and a lot of the links and any questions you guys want to ask us directly or your student or your teammates and such will be on Piazza. Discord will include announcements links and for events and all sorts of stuff. And we'll try to put it as much on every single platform as possible. But just be aware that those are the places that we're going to be talking to you guys.
Piazza is also where we're going to be posting slides and recordings. So if you miss a lecture or if you want to go back and review content from a lecture, that'll be the place to go. Assignments will be there as well. All right. So you guys all did the application, so you may remember this question. If anyone is interested in seeing the responses, check it out. It looks like Jerry won. Pretty good.
There's a bunch of right things there, but looks like a bunch of you guys chose the wrong answer, Stuart Little. Just saying. You guys are going to get dropped if you chose Stuart Little, and by next week, just saying. No, I'm kidding. But yeah, so there's our fun question. It's great to see you guys around. And now let's actually get into some of the details with today's topics.
Alright, so we're going to be going over power on the RAT. So with that, we're going to be talking about batteries, how your RAT is actually going to be powered, as well as a voltage regulator on the RAT, and safety, because when you're working with power, you got to be safe. And then in addition, we're going to be talking about the software that you're going to have to use this year, which includes Eagle. Autodesk Eagle is a PCB design software that we'll be using, as well as Cube IDE, which is what we're going to be using to program your RAT.
All right, let's get into it. So I'm going to talk a little bit now about batteries powering our RATs for the year. And so I'm going to talk a little bit about the types of batteries that we can choose from, and when you're choosing a power source for a personal project or for Micromouse. This is the sort of stuff that we take into account when we're trying to decide what to choose. So the first battery, of course, that we're going to talk about is lead-acid batteries. You might have seen these around. So this is the first type of battery. It's very heavy, very bulky. They're normally this big. You might they're car batteries, boat Batteries, they basically use them wherever they need a lot of power, and they don't really care about the weight. So they're super cheap because everything uses them, and they're really easy to charge. So those are some of the pros and cons of like lead acid batteries. And then the next type that we have is actually nickel metal hydride. These ones are actually also really common. You might have seen these in like AA rechargeables if you use any of those at home or in like your mouse or whatever. The thing with these is that they really do have a limited lifespan, so you can only charge them up and discharge them so many times before the like amount of power that you get from them starts to decline rapidly. The other thing is they have low individual cell voltage, which is why they're perfect for like replicating a AA battery. A AA battery standard is only 1.5 volts, and these guys nominally are like 1.3. So they're a good replacement for any like low power devices. But you know, they're also cheap. You can find them everywhere on Amazon, and they're easy to charge as well. So those might work, but they're not as like dense as we want, and they don't really provide that much power. So the last type of battery that we are actually going to look at, and the one that we're going to use, are lithium-ion and lithium polymer batteries, which you guys might be familiar with. They're everything that power your laptop, your phone, electric cars, everything nowadays, because they're very, very energy dense. So they store a lot of energy for the amount of weight that you know they contain, and they come in like a wide range of form factors. So they come in like pillowcases or like these round ones that you see here. The only thing is they're pretty expensive because they contain lithium and a lot of other like rare metals, and you know, they are complex to charge because of their chemistry. So of course, as I already said, these are our batteries, our lithium ion, actually these are lithium polymer batteries. These ones have a 1200 milliamp hour capacity, which essentially means that you could pull 1.2 amps from them for an hour before they die. They also have a 3.7 nominal voltage, which is, you know, the voltage that they'll put out when they're fully charged, or actually right when they're at 50%. So we actually use 2 of these on the rat because they provide a good amount of power that we need, as well as it's a good balance between power, weight, and you know, charge. And we use 2 of them to obtain 7.4 volts because our motors, as you'll see in the next lecture when we talk about motors and the rest of that stuff, those require more than 6 volts in order to run properly at full speed. So we use 7.4 volts as our power supply. And now I want to talk a little bit about safety with batteries, because we're going to be giving you guys these batteries essentially for the year. And one thing when it comes to using lithium polymer batteries is that they're pretty dangerous. You know, you got to treat them nicely with respect. So one thing that could happen here, this is actually an instance of someone overcharging a lithium polymer battery on purpose, just to make it explode. Of course, that should never happen, and it probably won't if you follow some good battery handling tips. So we're going to give you a charger. It looks something like this. And essentially it just has a little IC on it that knows exactly how to charge these batteries and how to deal with them to make sure that they're safe. So to keep these batteries, like, you know, in their ideal condition, I've got a couple of rules here that you're going to want to follow, like never discharging below 3 volts per cell. Below that limit, they actually start to degrade. They're not going to explode. The batteries aren't going to explode. But you might damage your batteries and you know, not have a functional rat on the day of a competition, which actually we saw last year. Some people didn't charge the batteries all the way, and their rats just, you know, didn't work. And they were like, well, we have to charge them. What are we going to do? So yeah, so it's a good idea to, you know, charge them before they get low. There's nothing wrong with charging them more often than less often. Of course, don't leave them on the charger all the time. But certainly I would charge them, you know, when you see your rat get a little slower. Or we do actually on our rat have a point where you can measure the battery voltage with the voltmeter, so you can see what they're actually at, so you know when to charge them. And then lastly, like if any batteries become puffy or look a little abnormal or they get warm or something, just stop using them right away. I just want to tell you that, and just let us know and we'll figure it out. They're not good. They're not like super dangerous. Like that image might have scared you guys a little bit, but you know. I just want to emphasize safety with these things because they can be a fire hazard. So yeah, now that I've talked about fire for a second, we can talk a little bit more about something fun. So,
Alright, so we're going to talk about voltage regulators and how we're actually going to use batteries and be able to use the power in a battery in a way that's useful to us. So actually stabilizing our power source. So why do we need voltage regulators? To keep that power from the battery stable so that we can use stuff like a microcontroller or our sensors or anything else that we have on our rack. Because otherwise, there is a lot on the rack, including our motors, that is going to draw a lot of current and could cause drops in voltage or spikes in voltage, just depending on what you're doing. And that's not going to, and that could have problems. If the voltage drops too low, you know, that's going to turn the rack off, and you don't want your rack to be turning on and off while it's running. So using a voltage regulator is going to keep our voltage at this nice steady level so that we can use 3.3 volts in our case any time. So about voltage regulators in general, there are a lot of different types of voltage regulators, but the ones that we're going to be using are linear voltage regulators. And so they're actually going to behave like a variable resistor. You don't need to know necessarily too much about how the circuit works, but if you are curious, here it is. You basically have an op-amp and a transistor, and based on that, the transistor is going to actually burn off any excess voltage that goes through it. So that's going to keep the output voltage at a steady level. So we're going to burn off any of that excess voltage using the circuit. But that's all baked within this this IC here, which is actually a voltage regulator, like you'll see, and you'll actually solder yourself on the rack. So you can basically just use this component to do this job for you. So the one we're actually going to be using is looks like this. It's a through-hole component, so if you've done through-hole soldering, it's going to be very easy to solder on, and even if you haven't done through-hole soldering, it's definitely going to be easier than some other small parts. It's a 3.3 volt regulator, so since the microcontroller uses 3.3 volts, that's perfect, and there is 800 milliamps max current draw from it, which is more than we'll need for anything on the rack, except for the motors, but the motors are actually not going to use the power from this, they'll use it directly from the battery. The Nucleo has its own voltage regulators on it. That's the microcontroller board that we used. We'll show you that a little bit later. But we're not using them because we wanted to actually have you guys sort of get a sense of how this circuit is set up, and because you're going to need to implement it when you come in the winter, when you make your own wrap PCB, or your own mouse PCB, you'll actually have to design the voltage regulator circuit, and that'll be part of the assignment as well. So when you actually do that, this LD1117, that will be, that's our voltage regulator, but this schematic actually also has these additional capacitors, and the capacitors are bypass capacitors, or so they actually act as like a low-pass filter to keep that voltage level smooth, and that allows everything to work here very nicely.
all right, yeah, first of all, do we have any questions? I forgot to ask after the batteries, but do you guys have any questions about the batteries or about our linear voltage regulator or any of that sort? If not, then we can keep going and talk a little bit about software and what we're going to be using. Yeah, what's that?
So like for the voltage regulator or whatever, it said it has a transistor that burns off excess voltage if it goes too high. What if it goes too low?
If it goes too low, so these voltage regulators, they're only like designed to burn off voltage. So there's only a certain point, like that's slightly above like the 3.3 volt target that you need to be at in order for that voltage regulator to actually keep that 3.3 volts. So inside the specification sheet, if you were to look, it'll say like, here's the minimum voltage that you need to feed into this to get your 3.3 volts out. So if you go underneath, then your output's invalid and it will do bad things. But that should never happen, so we're good. Any other questions? Nope. Okay, then we'll go on. So here's some of the software that we're going to be using with our RAT. We already talked about this a little bit, but we have STM32Cube IDE, which is essentially our programmer for our Nucleo boards. It's Eclipse-based, so if you've ever written in Java before, you might be familiar with Eclipse. And yeah, it's a little more powerful than Arduino IDE. You'll learn more about both of these softwares in our first assignment, which we'll talk about here in a second, but just to go on a quick overview. Again, Autodesk Eagle is what we're going to be using for our schematic and PCB design, and we'll teach you how to use all the software and how to design everything, and it'll be really fun. So, yeah, speaking of assignment 1.1, here it is.
So, in this assignment, we're going to actually do sort of a lot of different things to get all set up and just get started with everything. So that includes just installing the software we're going to use, and also creating a schematic in Eagle. You're actually going to design the voltage regulator schematic, kind of what we talked about and even showed here. So you can actually learn how to lay that out in Eagle. That'll help you eventually design your PCB film link recorder. And so then we'll actually soon, we'll give you your RAT PCB that you're going to solder some of together, including the voltage regulator circuit, as well as headers and everything to just plug in to get started, to be able to turn your RAT on for the first time, make sure everything works. And then lastly, you're going to do a little bit of coding in Cube IDE, just to get familiar with it. You're actually going to be turning on an LED that is on board the microcontroller we're going to be using. So that's really just to get you guys started with programming in this software here. So our initial due date was going to be Friday, October 22nd. We're probably going to extend that just based on how things are going with, we're not quite ready to get you guys kits yet, more on that later. And also we have a soldering workshop that's coming up, which might be helpful. So we might extend this deadline a little bit more.
Yeah. So let's see. So here's a couple reminders before we talk a little bit more about that assignment. So we've got the safety trainings that you guys might have seen in the syllabus. Those are due this Friday. So it's just a bunch of safety trainings that the department forces you guys to do before you can do anything in the lab, including just touching solder. So you guys are required to do that, and I'd recommend doing it sooner rather than later. They don't take too long. They're kind of painful because, you know, they're forced trainings, but I'd say they don't take more than 2 hours total. That's a stretch, actually.
And the sooner you do it, the sooner you can get started with everything else. So do it ASAP. We also have our second lecture coming up next week at the same time. Place is to be determined, so we'll send that information out as soon as possible. There's been some issues with the events scheduling stuff, so
as you can see with the projector here.
Hopefully that'll be a lot smoother and actually start right on time. But we've got that to look forward to next week.
And we've also got a soldering workshop. If you guys haven't soldered before, I know many of you have, but a lot of you haven't. So we do have a workshop that's going to be next Thursday from 6:30 to 8:30 in the IEEE lab. And that's just going to go over the complete basics of soldering as if you hadn't before. So if you haven't done it at all, then I would not advise starting with the RAT that we're going to give you in assignment 1.1. I'd advise you to go to this workshop. And you'll get to solder a little cool PCB that just says IEEE and learn how to do through-hole soldering. It'll be really cool. Actually, is that in the makerspace? It might be in the makerspace.
They might have some of it in the makerspace, but for now it's in the lab.
Yeah. Anyways, pay attention to the Discord.
Yeah, that's
I believe there's also an RSVP for that.
Sorry, what?
I believe there's also an RSVP for that workshops wants, so if you do want to go, please do RSVP.
I actually linked that in the assignment, which we'll be releasing on Piazza after this lecture. So you can find it there. We'll also send it in the Discord and stuff too.
All right. Quick question. Does anyone have any questions about what we just went over? Anything? Nope? Okay, cool. Let me tell you a little bit about getting your hardware RATs to you guys. we didn't get the like project boxes that we were gonna give you until like 2 hours ago. So we have all the parts, we just need to put them together and get them out to you guys. So once you guys have submitted your deposits, once we see that your team has, then we will go ahead and give you guys a box, whether that be, I think, probably we'll do the main distribution at next week's lecture, or if you come during our lab hours, then you can probably get a box then. Let's see, so that's the deal with that, yeah?
But most of the assignment, you actually don't need the hardware at all, because a lot of it's just installing stuff or doing stuff in Eagle. So you can actually get started on probably 75 to maybe even 90% of the assignment without having access to the hardware yet. So start on the assignment this week, and then you'll finish it up next week with the actual hardware.
I think that's about it we had for today, right?
Yeah, that's all we have in terms of content-wise. I highly would recommend that you guys should figure out who's on your teams if you haven't already. We send all that information out, the roster. So find who's on your team, say hi. Maybe you can figure out some icebreakers to do, or if you like to do icebreakers.
Yeah, what's up? Actually, you know what?
Signing the schematic and like the writing the code, is that individual, like everyone has to do it, or is it like as a team?
It's turned in as a team.